Good morning, everyone. My name is Renuka, and in this presentation, we'll be delving into the comprehensive analysis of prevalence of eating disorders, a critical issue in the realm of mental health. And my data set is from Kaggle, where where my data consists of different disorders across countries over years 1990 to 2019, and it consists of 6,420 observations with columns of country code, year, prevalence rates for schizophrenia, depression, anxiety, bipolar disorders, and also eating disorders. And my target variable for predicting modeling is prevalence of eating disorders, and my goal is to build models to predict national rates of eating disorders over time. And I first started with exploring my data using ggplot, and the first I did is histogram, and after that I did scatter plots to detect a relationship between eating disorders and schizophrenia, depression, anxiety, and bipolar disorders for each. So this was my data, and I first did a histogram. So I did the frequency of distribution of eating disorders over time, and after that I started doing scatter plot for schizophrenia based eating disorders, depression over eating disorders, anxiety over eating disorders, and bipolar disorders over eating disorders. From here, I came to realize like everything has a positive correlationship. Bipolar disorder, anxiety, schizophrenia, except depression, where it has a linear correlationship and more like a negative correlationship when compared to other disorders. And after that, I started doing correlations and collinearity to understand my data better. So I created a heat map and also understand the data, whether the correlationship is positive and negative. And and after that I did collinearity, where the correlation matrix suggests potential collinearity issues given the strong correlation between some predictive variables. So I did correlations for different variables, where it shows for schizophrenia, uh, anxiety, and bipolar disorders, it has a positive correlation of 0.475, the p-value 0, indicating it's statistically significant. And for depression, it has a negative correlation, minus 0.0905, indicating it has a negative correlation, that is, it is inversely proportional, where if a person has depression, he has decreased incidence of having eating disorders. But coming to schizophrenia, anxiety, and bipolar disorders, they have a positive correlation, indicating if a person has a schizophrenia, anxiety, or bipolar disorders, he has increased chance for eating disorders. I also analyzed it. I also showed it in a heat map, where the dark color indicates a positive correlationship and a light color indicates a weak or negative correlationship, and in between colors indicates more like a negative correlationship. I did showing using various plots so that we can understand the data better. After that, I started doing data cleaning and shaping, where I have removed my missing values in my data, so that I also did imputation, so that the missing values were replaced with mean and mode. After removing the missing values, I started removing outliers. In my data, I didn't remove more outliers because while I got to know my outliers, I can see there are specific countries, Austria and Morocco, but these countries have an increased prevalence of eating disorders too. So I decided to retain my outliers and do imputation and replace them with mean and mode. Mm. I removed my these are my outliers. These are my outliers, where I analyzed like Australia and Monaco are having an increased number, but these also have increased prevalence of eating disorders. So I did imputation, and I showed that in a box plot, where these are the outliers, and after imputation, these are the outliers, which there is a decreased impact of outliers. So after doing my outliers, I did log transformation. This I did because after analyzing my outliers, I did evaluation of distribution, where I did a Shapiro-Wilco test to understand the normalized, whether the data is normalized or not. And I realized my data is not normalized. So I did log transformation. Mm. And after doing my log transformation, my data is my data, which is more rightly skewed, is somewhat it somewhat became normal. And after log transformation, I started doing standardization, and also I did minimax scaling, so that my data is somewhat standardized and have, so that I can do predictive modeling and will have a good results. A strong result, so that I can interpret the data better of my eating disorders and everything. After standardization, I did PCA, where I got to print my data, and I have realized PC1 as 1.5, PC2 has 1.10, PC3 has 0.7, where these are the standard deviation values, where after doing PCA from 1 to 5, we can see that there is a decreased number from 1.5 to 0.4, which indicates that the data is being normalized, and there is a decrease in variance between the data. And in the cumulative progression, you can see like the data is changed from 0.48 to 0.88 and 1.0, where it's showing the data is being normalized, and the variance is being decreased. And after I did standardization, as I said, and PCA. And after that, I started doing feature engineering, so that it enhances the data set by introducing meaningful variables that capture temporal, cyclic, and seasonal patterns of eating disorders, where I want to see like particular year has any prevalence, or particular time has any prevalence. So I started doing feature engineering. I introduced yearly trends, temporal lag, cyclic features, and also seasonal trends, where I can analyze my data. For yearly trends, I kept a bin of 5 years, and for seasonal trends, I try to analyze whether it is more common in summer or winter. And for temporal lags, I try to analyze between this year and the particular next year. I standardize my data, and I can see like it gave me a good idea of how eating disorders are particularly being more developed, or being more associated with other disorders. After that, I started doing linear regression model, where I involved particular packages. And after that, I split the data into training and validation data. And I also did a holdout method and careful cross validation for prediction of my data, where I got an estimated standard deviation of p-value, estimated standard deviation and t-value, where we can see like schizophrenia, anxiety, and bipolar disorders have 0.49, 0.30, and 0.700567, where it shows a positive correlationship, and they are like positively associated. And p-value, as we already discussed, is statistically significant. And we can see the multiple r squared 0.643, which indicates like it has an accuracy, it is sufficiently fit, and with a variable with an approximately 64% of variability in the data, it is showing the prevalence of the data. And the root mean square is 0.137, and the holdout and cross validation is of 0.13, suggesting like they are suggesting they have very less error, and the data is statistically significant. And after that, I started doing random forest. I split the data as same, and I also did predictions on holder. I did cross validation and holdout set for validation of data and for prediction of my data set further. And from here, I got my root mean square root of 0.15 and 0.017, which indicates that I have a very good accuracy, and they are less than linear regression, indicating that it is a very this model helps in analyzing and also accurately forecasting eating disorder prevalence. After that, I started doing support vector model, where I also did same, like dividing the training into validation data set, and further evaluating the model using careful cross validation, where my root mean square errors of 0.09 and 0.08, suggesting that the error is somewhat more when compared to linear regression and random forest. So I also did hypertuning to analyze. It is based on for cross validation. It is because of cross validation and a holdout method. So I got RMSE of 0.09, and also with a C of 0.1 and radial kernel. With so this suggests like it was same as cross validation done with SVM. So this suggests like SVM model is somewhat less useful or somewhat helpful, somewhat less like, can be less predictable for using this data because of its complexity of of different with different features. So I did comparison of models between data sets. So it shows like random forest is a very good fit for this data set compared to linear regression and SVM. First we'd go for random forest, then SVM, and then linear regression. And then we started doing ensemble where we did predictions by averaging. So the root mean square error we got is 0.072, which is somewhat perform good when compared to uh, linear regression and SVM, but somewhat less when compared to random forest. So although as ensemble combined the strength of the data, it didn't provide a better result when compared to random forest. So a further did is bagging using the ensemble of using bagged ensemble for random forest, where I got a root mean square of 0.059159, which is indicating an impressively like low RMSE of 0.0159 on validation dataset, which is which it more like having a very good accuracy for eating disorder prevalence compared to other models. And after that I tried to compare ensemble to individual models, where I got an individual model performs better than the ensemble model. So from here I tried to analyze like so from here I got to like this would be helpful in predicting the eating disorders associated with other disorders. So this data is helpful in understanding the how eating disorder is associated with other disorders, and also these models where we can predict like which model is helpful in predicting the data. And we did data pre-processing so that the data is accurate, and also the way we did statistical so that it will be further useful for statistical analysis and also for machine learning models. So that's the need for doing the data pre-processing. Thank you.